Okay. Right now. Okay, so my problem says look at the absolute extrema of the function if they exist over each interval. So the function given f of x equals root 4 minus x squared. So first step, take the derivative. Use the chain rule. F prime x equals 1/2 4 minus x squared to negative 1/2 times negative x, which is the derivative of the inside function, which equals negative x over 4 minus x squared, or root 4 minus x squared. Okay, so the first interval is negative 2, 2, closed on both sides. You set the derivative equal to 0 in order to figure out where x equals 0. And that's where the critical points are. Or, yeah. Okay, so you find that x equals 0 and x equals plus or minus 2. So you substitute 0. So you substitute 0 into the original function, 4 minus x squared, or root 4 minus x squared, and you get plus or minus 2. Now, y cannot equal negative 2 because this can never be. Wait, hold on. Yeah, this can never be a negative number because the square root. You can't take the negative of a square root, or you can, but it won't be real. Okay, so there's an absolute maximum at 0, 2. So then you take f of negative 2, and that equals 0. So there's an absolute minimum at negative 2, 0. And then you take f of 2, which also equals 0, and there's another absolute minimum at 2, 0. So 2 absolute minimums and 1 absolute maximum. And that's all in this interval. Second interval is negative 2, 0. It's closed on the left side. So you find what x equals again when you set the derivative equal to 0. And then the only one that's in this interval is negative 2. So f of negative 2 equals 0, and there's an absolute minimum at negative 2, 0. Okay, the third interval is negative 2, 2, and that's open on both sides. And you set the derivative equal to 0 again. You find where you find the x values, and then you substitute 0 into the original function, root 4 minus x squared. Okay, and you get plus or minus 2 again, and it can't be negative 2. So there's only one absolute extrema on this interval because it's an open interval, and that's at 0, 2 is an absolute maximum. The fourth interval is 1, 2, closed on the left side, open on the right side. Again, you set the derivative equal to 0, and none of these x values are in the interval, so there is no absolute extrema on that interval.